start with our introduction. What is a HPLC? HPLC, or a high performance liquid chromatography, is a laboratory technique that allows for the very efficient separation of a small amount of the components in the mixture. The technique has essentially the same operated basis as liquid chromatography, but is better in terms of separation. The tiny particles that are inside the column comprise the stationary phase, and because they are so tightly packed, the mobile phase solvent must be forced through the column under very high pressure. How do we identify the sample in this chromatography technique? The identification of sample is carried out by comparison of their retention times. The ratio of peak should also give the same amount of the components present. Reverse phase partition in HPLC employs a polar mobile phase and a non-polar stationary phase. This is a very common form of HPLC. For our experiment, we will use a column consists of a layer of an alkane C18, which is chemically bonded to the very small silica particles. The alkane stationary phase is non-polar. The silica is the inert support material with high surface area, and for our mobile phase, which is a polar solvent, we will use water or acetonitride. Our first objective is to determine the retention time of a standard solution, which is caffeine, that we use in this experiment. The second one is to identify the caffeine peak in a soft drink sample, and the last one is to determine the amount of caffeine in soft drink sample using the response factor method.
Next, we have plot diagram of HPLC. First component that we have is solvent reservoir. Next component is pump and followed by ejector. After that, we have column. There are two types of column, which is gate column and analytical column. Other component in HPLC is detector, and lastly data system and display.
The function of the component. For the first component is solvent reservoir, which is connect to pump to remove gas, degasser using ultrasound or sputter method. The second component is pump that force the mobile phase to flow through the packing, which allow the compound to deliver mobile phase throughout the system, and also to maintain a stable flow and avoid pulsation. The third component is injector that responsible to put sample in the mobile phase. The fourth component is guard column and analytical column that designed to increase the lifetime of analytical column by prevent deactivation and clogging applying the adsorption and minimize band broadening method. Next component is detector that accountable respond to a mobile phase bulk property, which modulate by the presence of solute respond to some property of the solute that is not possessed by the mobile phase. Last but not least is the data system and display that allow computer to display the result from the analyzed data of the compound.
So, for the result, I'm going to explain about the retention time. For caffeine standard, the standard caffeine solution had a retention time of 2.482 minutes. This is a benchmark to identify caffeine in the samples. Caffeine in a Coke, the retention time was 2.481 minutes, very close to the standard, confirming the presence of caffeine in the Coke sample, while caffeine in Lavita, the retention time was 2.019 minutes. While this is slightly different from the standard, the distinct peak likely correspond to caffeine influenced by metric effect or other sample-specific conditions. Next, for the peak areas, Cook, the peak area for the caffeine was 7001.12, representing the amount of caffeine in the sample, while Lavita has the peak area for caffeine is 3.48617 times by 10 power of 4, significantly larger than Coke, indicating a higher caffeine concentration. Next, comparison of caffeine content. Coke has 1121.2 ppm, which is equivalent to 1.1212 mg per ml. Lavita has 5582.8 ppm, equivalent to 5.5828 mg per ml. The caffeine concentration in Lavita is approximately 5 times higher than in a Coke, which is consistent with the nature of these beverages. Lavita, being an energy drink, is expected to contain more
From the
caffeine.
result given, data that we're able to analyze for the compound, the first compound is standard caffeine that has retention time 2.482 minutes and peak area is 6244.49, while the retention time for caffeine in Coke is 2.481 minutes with peak area that takes 7001.12. Lastly, the value of retention time of caffeine in Levita is 2.019 minutes with peak area is 3.4617 times 10 power by 4. To get the value of response factor in caffeine standard RF, we must divide the value of peak area of standard caffeine with the value of concentration of standard caffeine. Then we get the value factor of caffeine standard, which is 6.24449 times by 10 power of 3 mg over ml. From the calculation before, we are able to locate the amount of retention factor that allows us to calculate the concentration caffeine in the unknown concentration, which in Coke and Levita. By divide the value of peak area in the sample with retention factor, we are able to obtain the amount of concentration caffeine in Coke sample, which is 1.1212 mg over ml. To convert the value in ppm, we know that 1 mg over ml equal to 1000 ppm. Thus, the final value of concentration caffeine in Coke sample is 1.1212 times by 10 power by 3 in unit ppm. We apply the same calculation method to find the value of concentration caffeine in Levita sample by divide the peak area with retention factor value to get 5.5828 mg over ml. To convert the value in ppm, we know that 1 mg over ml equal to 1000 ppm. Thus, the final value of concentration caffeine in Levita sample is 5.5828 times by 10 power by 3 in unit ppm. We apply the same calculation method to find the value of concentration caffeine in Levita sample by divide the peak area with retention factor value to get 5.5828 mg over ml. To convert the value in ppm, we know that 1 mg over ml equal to 1000 ppm. Thus, the final value of concentration caffeine in Levita sample is 5.5828 times by 10 power by 3 in unit ppm.
From the experiment was successful in identifying and measuring caffeine in Coke and Lavita. The retention time matched closely, confirming caffeine was present in Coke had 112.1 and Lavita had a much higher amount at 5582.8, which makes sense since energy drinks usually have more caffeine than sodas. There were small differences in retention time, possibly due to other ingredients or minor experimental error. Overall, the experiment went well and showed that HPLC is a good method for analyzing caffeine in drink.
At the end of this experiment, we can conclude that the retention time of the standard solution was specifically 2.482 minutes, which was successfully achieved. We were capable of identifying the peak area of caffeine in the compound of soft drink. Thus, the Coke we gained 7001.12, while in Levita we gained 3.48617 times 10 power of 4. In addition, we managed to determine the amount of caffeine in Coke and Levita using response factor. The concentration of caffeine in Coke was calculated at 1.1212 times 10 power of 3 ppm, while the concentration of caffeine in Levita was 5.5828 times 10 power of 3 ppm.